Alright, so linear inequalities, and this is covering in section 6-5 in your textbook, getting near the end of chapter 6. What is a linear inequality? Linear inequalities are basically combining ideas that we've seen before, and that would be linear equations combined with inequalities. So then what is a linear inequality? A linear inequality is exactly like linear equations we're used to seeing. We've seen y equals mx plus b, we've seen standard form, we've seen point slope form, but instead of the equal sign, a linear equation means equal sign is involved. We're replacing the equation sign, the equal sign, with an inequality symbol. So less than, greater than, less than or equal, greater than or equal. Like we covered during the first quarter. And like when we covered this in the first quarter, what happens when we have an inequality symbol is that we're talking about multiple numbers that could be the answer. So the solution to a linear inequality is any ordered pair that makes the inequality statement true. It's less strict than the equal sign. The two sides of the equation don't have to be equal, they just have to fit with what the inequality statement says. So this is an example, y is less than or equal to 2x minus 7. So how do we tell then whether something is a solution? And we've done this with basic equations, and we've done it with systems of equations. Now how do we tell with an inequality? The same way you always tell whether something is a solution or not is plug it in. So we're going to plug in -2 for x, 4 for y, so y is 4, and I can put those in parentheses, but there's its only thing on that side. X is 2, or sorry, -2. So when I'm deciding is this a solution or not, I want to simplify both sides. So 2 times -2 is -4, plus 1. 4 is less than, -4 plus 1 is -3. So is that true? We have to do a little more thinking than when there's the equality sign, but is that true? No, 4 is not smaller than -3. Remember, the alligator wants to eat the bigger number, and in this case the alligator is not eating the bigger number, so no, this is not a solution. So numerically, we can test whether something is a solution or not. Identifying what solutions actually are, the easiest way to do this is graphically. You can certainly pick some numbers and figure out that, oh, if x was 0, y could be 5, or -5, just looking at this equation. However, there's many answers. So if you remember with inequalities, how we figured out what numbers were solutions was we looked at the graph. We looked at visually what was shaded in on the graph. So just like that, we're going to graph the equation. So how do we graph a linear inequality? Well, the good news is most of the things we're going to do are the same as what we did when we graphed linear equations. So you think back to graphing linear equations. How do we graph our equations? Well, first thing we wanted to do was make sure our equations in slope-intercept form, because we want to know the slope of the line, and in this case the slope is 2/1, and we wanted to know the y-intercept of the line, and in this case the y-intercept is -3. So if I graph this, I'm going to put a point on the y-intercept, and I'm going to go up 2/1, up 2/1, up 2/1 to get my slope. Here is where now things become a little bit different. So we've got where our line is going to be. Now if you remember when we did inequalities and we graphed those on a number line, we would graph, so say this is the inequality, x is less than or equal to 5. We would graph at the value of 5, and we would do first, we would say, okay, open circle or closed circle. How does that translate into our inequalities now? Well, when we have less than or equal or greater than or equal, We want to say, okay, when the equal sign is there, we're saying we want to include the value. So for up here in our x is less than or equal to 5, we wanted to include 5, so we filled it in as a closed circle. So when we want to say we want to include the values, we want to say it's equal to, we want to include the values that are on the line, we want to do a solid line. So we're going to connect our points with a solid line. But what if we didn't want to include the points? What if it was just less than or greater than? That tells us that the points on the line don't actually count. They're just a boundary, because we want values that are less than the line or greater than the line. To show that, what we'll do is use a dashed line. So step 2 is decide what kind of line are you going to use. Are you going to use a dashed line, or are you going to use a solid line? So any of these points now, if I plugged them in on the line, like let's pick 2, 1. If I plug in 1 for y and 2 for x, we get 1 is less than or equal to 4 minus 3, 1 is less than or equal to 1. Is 1 less than or equal to 1? Yeah, so that point checks out. Are the points on the line the only one that count? The answer is no. So I'm going to pick a point just because I have some extra knowledge here. Let's say I pick the point 3, -1, and I plug that into my equation. So kind of going back to this idea, sorry, I kind of skipped ahead. What did we do with the inequality? We chose solid circle or open circle. Same way we're going to choose solid line or dotted line. But then what was the next step we did? Well, we had to shade. We had to say, okay, well, it's going to include other values, not just 5. It's going to include all the values that are less than it. So our second piece, or our step number 3 here, is going to involve shading. So how do we decide what kind of shading we're going to do? And we're actually going to be shading a portion of the graph. Well, we want to see what other points would be included in the solution. So if I pick the point 3, -1, back to this now, and I plug in -1 for y and 3 for x. I get -1 is less than or equal to, and this is 6 minus 3, which is 3. -1 is less than or equal to 3. Is that true? That is true. So that means that everything that's on this same side of the line, where this point was, I found this point was true. It worked out. All the points that are on the same side of the line are also going to be solutions. So in here would be our solutions. What if I picked a point over here though? Let's say, let's say I picked the point 0, 0. And I'm going to squeeze this in up here because it'll be pretty easy to figure out. If I plug in 0 for y and 0 for x, I get 0 is less than or equal to -3. Is 0 less than or equal to -3? The answer is no. So this area right here, these represent not solutions. If it's not shaded in, so that shouldn't even be there. If it's not shaded in, then it's not part of the solutions. So to do the shading, you want to choose a point on either side of the line, test that point, and if it is a solution, you shade on that side. If it's not a solution, you shade on the other side. So anything that's colored in is considered a solution to this linear inequality. There's not one solution, there's lots of them, an infinite number. So let's get to an example of a little bit harder, and this is going to be the I do, because there's one thing, oh whoops, I meant to make this a minus sign, I believe. There's one thing I want to remind you of when it comes to graphing linear inequalities. So step 1, I said we want to use slope-intercept form. So if I change this into slope-intercept form, I'm trying to get y all by itself. So I have -3y is less than or equal to 2x minus 9. If I get the graph of this, I can visually see where all the solutions are. So now I'm going to divide both sides of the equation by -3. The reason I wanted to make sure you saw this was, remember what happens with an inequality when we divide by a negative. Divide by a negative means when we get our solution here, negative 2/3 x, and negative 9 divided by negative 3 would be positive 3, then you need to remember to flip the sign. So our sign now becomes greater than or equal. So if I'm going to graph this, I'm going to use the y-intercept of 3 and the slope of negative 2/3. So down 2 over 3. Step 1 was just graph the points that are on the line, and I can't really fit any more on my particular graph. Step 2 is now think about when you're graphing a regular inequality. We decide open circle or closed circle. Well, we're finding out filled in line or dashed line. Because there's the equal sign, we're saying everything on the line counts, so we want to use a filled in line. So open circle, closed circle, filled in line, dashed line, and then the last part is shading. So which way do we want to shade? Do we want to shade above the line, or do we want to shade below the line? Well, how do we decide? Let's pick a point. I'm going to pick, and generally speaking, you want to pick the easiest point you possibly can. You can pick whatever you want. But if I pick the point 0, 0, plug in 0 for y, plug in 0 for x. 0 is greater than or equal to 3. If we can pick a point, 0, 0, that's going to be the easiest point you can pick. I mean, if 0, 0 is not available, pick 1, 1. You just want to pick a point that is clearly above or below the line, so you know which way you're shading. Is 0 greater than or equal to 3? The answer is no. So that means all my shading is going to go on the opposite side. So where are solutions? Solutions are anything that's colored in. So it could be something like 3, 4 is a solution. 100, 100. 4, 1. Any of these points that are colored in, including 0, 3, any of those points would work as a solution to this linear inequality. So now it's your turn to try a problem. Graph the solutions of this linear inequality. When you finish, try and identify a couple points that would be part of the solution. So by graphing, we're showing all the solutions. So go ahead and pause, and then here's your solution. So we need to change this into slope-intercept form. Negative 3y is greater than negative 4x plus 12. I want to divide by negative 3 on both sides. Y is, and remember to flip that sign if you didn't, all it does is make your shading on the wrong spot because you have greater than and not less than. So 4/3 x minus 4. So when I graph this, my y-intercept is negative 4. My slope is up 4 over 3. Filled in circle or closed circle, other words, filled in line or dashed line. Well, I'm going to create this with a dashed line because there's no equality. We don't want to include the line. We just want to show it as a boundary. So no equal means it's not including the line. And then are we shading to 0, 0? Or are we shading the other way? I'm going to pick the point 0, 0. 0 is less than 4/3 x. Whoops, put in 0 for x. So 0 is less than negative 4. Is 0 less than negative 4? Nope. Not true. So our shading is going to go on the opposite side. Your solution is the graph. And it describes any of the points. 3, negative 1. 4, negative 3. 2, negative 4. 1, negative 4. However, 1, negative 3 is not a solution. If it's on the line, points on the line are not solutions.